Hi everyone, this is Aruna Arichami, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about the transaction concept under the database management system subject. In this thing, we're going to see about the schedules and also different type of a schedule. Kindly watch my previous video. In that, I'm detailedly explained about the definition of a schedule along with the different type of a schedule with an example. So today we're going to see about the types of a scheduling. Schedule can be classified into two types. One is a serial schedule, another one is a non-serial schedule. This case I have to explain in my previous video. And also your non-serial schedule can be again subdivided into serializable and non-serializable. When we can call it as a serializable means only it will support the conflict and the view serializability. Then only the particular schedule is a serializable. If it is a non-serializable, it will fail to be a non-conflict and it cannot be in a view serializable. In this case only it will move to the non-serializable schedule. In this case we are having a two thing. One is whether it can able to recover that particular schedule, or it could be non-recoverable by the schedule. If it is a recoverable, definitely it will have a three types: strict schedule, cascadeless and cascading schedule. Today we are going to see about the non-serial schedule alone. So what do you mean by serial schedule and non-serial schedule? Means serial schedule is there is no concurrency is allowed over here. In serializable, the concurrency is allowed. Multiple transaction can be executed concurrently. But in my serial schedule, transaction can be executed one after another. And also in my serial schedule, your resource utilization and CPU throughput is only it will take a lesser thing. And also by using a serializable, we can able to improve the throughput rate as well as the utilization. In serialized schedule, it is less efficient, but here it is better than the serial schedule. Why it could be said over here is it will leave only after one particular transaction is completed in that particular schedule. So only it is a less better when compared to the serializable. Most cases for improving our throughput rate and resource utilization in all my real world entity, we are going for a serializable schedule. That is a non-serial schedule. So what do you mean by serializability is nothing but in a schedule of a transaction n, that could be called it as a serializability. All your non-serial schedule, we can call it as a serializability. Now we going to convert or equivalent the non-serial schedule to the serial schedule of the same transaction. So for example, if you are considering the read A, it will read certain amount and it will update the write. It is partially executed. It will leave the resource for the another transaction to do the another task. So this case only we can call it as a non-serial schedule. In this case, we have to check whether my instruction in that particular schedule can be executed in a chronological order or it will have a certain order can be followed or not. That could be checked by using a whether it can be supported the conflict serializability or a view serializability. First, we're going to see about the transaction. Transaction is nothing but a piece of work. That is a single logical operation in a database. We can call it as a transaction. But in a serializability, a multiple transaction can be run concurrently in a particular schedule. All the sequence in which operation ought to be performed as an action or analytical processing in the particular database. This could be called it as a serializability. So serializability, it is nothing but it is one of the property of my system. It will describing how the process can be shared the data and how it can improve the throughput rate. That could be called it as a serializability. But here also we have to follow certain sequential order, and here we are going for a no overlapping of a execution. Just we are swapping the transaction. It will not overlap the each and every transaction in a particular schedule. Only it will perform the swapping of the instruction in that particular schedule. So there is a two types of a schedule. Important thing is a non-serial and this is a serial. So this case we already discussed in the previous thing. Now we're going to see about the conflict. What do you mean by conflict? So in a particular schedule, is in a particular any transaction that order is conflicting, it is operation that could be checked by using a conflict serializability, because each instruction in a schedule can be executed in a certain order. That we're going to check whether it is a serial execution or it could be having any conflicting operation present in that particular schedule. For checking that thing only we are going for a serializability. So how we are checking means conflict is can be depend on the same data item. That is the one major thing is a write. So where it could be occur means only with the help of these four transaction only it could be occur. If it is a read and read, both the transaction can have the read operation. Definitely it does not have a conflict. If we go going for a read and write, definitely we can come across the conflict. Write read, this is also conflict. Write this is also conflict. So these three cases only we going to consider for the conflict serializability. In this case, where the swapping can be done. If I go for a swapping, is there any conflicting operations are present over there or not? That we going to check under the conflict serializability. How we can able to check this thing means here we going to use this type of a operation. First we have to check whether everything is belong to the different transaction. If it is a same transaction, definitely we have to check it is a conflict or not. They operated on the same data item, or at least one it will have a write operation. So this is the keys we going to check for the conflict serializability. For this thing only we are going for the precedence graph. That is the precedence graph. We study this thing in our data structure. So how we can draw the precedence graph means based on the sequence of the transaction can be executed in the schedule, we're going to draw a precedence graph. In the precedence graph we're going to check is there any cycle is formed. If there is any cycle is formed in that particular precedence graph, definitely it is not a conflict serializability. If does not have any cycle, there is a no cycle means definitely we can say it is a conflict serializability. If it is a conflict, definitely it could be a view serializability. When we can go for a view serializability means once your conflict serializability is not cases come across means only we can go for the view serializability. So what do you mean by view serializability means it is a view is equivalent to the serial schedule or not, that we going to check. So how we can able to check it means by using these three condition. In these three condition we going to use first condition is the first write, that is a read write. Second thing is first updater read, that is a write read. The third condition is the lost write, that is a final value which transaction to be updated. So these three conditions only we have to check it for the view serializability. For based on these three things we have to draw a dependency graph. If my dependency graph is a cycle is formed means definitely it will not be a view serializability. If there is no cycle formed in a dependency graph means definitely it is a view serializable. This is the how a conflict and view serializability can be checked. Thank you for watching my video. In my next video we are going to see about the remaining topics, that is a locking protocol and all.